Geysers are some of nature's most fascinating phenomena, combining the elements of earth, water, and heat into a spectacular show that has captivated humans for centuries. These unique hot springs have a remarkable ability to periodically erupt, shooting hot water and steam high into the air in a dramatic burst of energy. But what exactly causes geysers to act this way? And why are they so rare? To understand geysers, we need to explore the complex science of heat, water, pressure, and geology that makes these natural wonders possible. At the heart of every geyser is a powerful underground heat source, often linked to volcanic activity. Geysers are typically found in areas where magma, molten rock from deep within the earth, is located relatively close to the surface. This magma acts as a natural heater, warming the surrounding rocks and, by extension, any groundwater that comes into contact with these hot rocks. When groundwater seeps into the earth and encounters this heat, it warms up, often reaching temperatures far beyond the boiling point we observe at the surface. However, because of the intense pressure from the weight of the water above, the water doesn't turn into steam right away. Instead, it stays in liquid form, superheated and unstable. Imagine a system of narrow, underground channels and chambers winding deep into the earth. When water flows into these channels, it begins to heat up as it gets closer to the magma-heated rock. This trapped, heated water is under immense pressure, both from the water above and the weight of the surrounding earth. As the water temperature rises, the pressure builds, causing the water molecules to vibrate faster and faster. Eventually, the conditions become just right, and the water abruptly changes from a liquid to a gas in a process called flash boiling. This sudden expansion of water into steam takes up much more space, creating a surge of pressure that forces the water and steam up and out of the ground in a powerful eruption. This whole process repeats itself in cycles. After each eruption, the underground channels begin to refill with cooler groundwater. The magma heats this new water, and the buildup of pressure starts all over again. Depending on the specifics of a geyser's underground system, these eruptions can happen at regular intervals, as seen with famous geysers like Old Faithful in Yellowstone National Park, which erupts roughly every 90 minutes. Other geysers, however, have more irregular patterns, depending on changes in water flow, temperature, or geological shifts. The rarity of geysers is due to the unique combination of factors required for their formation. First, there needs to be a heat source, like a shallow magma chamber. Second, there must be an adequate supply of groundwater that can seep into the Earth's crust to interact with the heated rocks. Third, the underground structure must be just right, with narrow channels and chambers that trap and heat the water. Without all these components working together in harmony, a geyser simply wouldn't function. One of the most captivating aspects of geysers is the variety in their shapes, sizes, and eruption patterns. Some geysers shoot water hundreds of feet into the air, while others create gentle bubbling pools. The structure of the underground plumbing system, the twists, turns, and size of the channels and chambers, largely determines the behavior of each geyser. For example, a narrow, constricted passageway can lead to more explosive eruptions because the pressure buildup is more intense. In contrast, wider channels allow for slower releases of steam and water, resulting in more subdued eruptions. Geysers are also influenced by seasonal changes, environmental factors, and even human activity. During wet seasons, increased groundwater can lead to more frequent eruptions, as there's more water available to fuel the cycle. Conversely, droughts can reduce the frequency or even stop geyser activity altogether. Human influences, such as drilling for geothermal energy or the construction of dams, can also impact geysers by altering the natural flow of groundwater. The vibrant colors often found around geysers are another intriguing feature. Many geyser sites are home to extremophiles, microorganisms that can survive and even thrive in extreme heat. These heat-loving bacteria and algae produce colors ranging from bright oranges and yellows to greens and blues, creating a stunning visual display around geyser pools and runoff channels. The particular colors often depend on the temperature and mineral content of the water. For instance, cooler areas may host greenish algae, while the hottest zones are dominated by bacteria that give off an orange or red hue. Geysers have long fascinated humans, not just for their beauty, but also for the insight they provide into the Earth's geothermal processes. By studying geysers, scientists learn about the geothermal activity that lies beneath the Earth's crust, which can help in understanding volcanic and seismic activity as well. In some places, the geothermal energy that powers geysers is harnessed for human use, providing a renewable source of power. However, tapping into this energy can sometimes disrupt the natural geyser cycles, highlighting the delicate balance between preserving natural wonders and meeting human energy needs. The science of geysers reminds us of the power and complexity of our planet. They are a dramatic reminder of the heat and energy that constantly flow beneath the Earth's surface, hidden from view except in these brief, spectacular displays. Geysers connect us to the primal forces of nature, revealing a glimpse of the heat and pressure within the Earth that are usually only observed during volcanic eruptions. They are not just random bursts of water and steam, but rather intricate systems that demonstrate the interconnectedness of geology, water, and heat. In many ways, geysers are like living things. They breathe in the water that seeps into the ground. They feel the pulse of the Earth's heat, and they erupt in cycles as steady and reliable as a heartbeat. Observing a geyser's eruption can feel like witnessing the Earth itself come to life, reminding us of the planet's dynamic nature and the hidden energies that shape our world.